In this example, we'll see how to find the factors of a given number. Okay, so first thing is what we mean by factors. So let me create a file, print all factors.html. Okay, so what do we mean by factor? Let's say we have a number, it is 12. So what are the factors of 12? 1, 2, 3, 4, 6, and 12, right? So 1 into 12, 2 into 6, 3 into 4. Okay, so these are the factors. So how do we find out the factors of 12? So the logic that we'll be using here in JavaScript is we'll try to divide 12 by all the numbers from 1 to 12. Okay, so let's say first I divide 12 by 1. So what I will get? 1 into 12. Then I'll try to do 12 by 2. So I'll get 2 into 6. Okay, so what operator I will be using here is I will use the percent operator. So that will give us the remainder. So what will happen if we find a remainder? When I divide 12 by a number, if the remainder is 0, that when I divide 12 by a number, when the remainder is 0, that means that 12 is divisible by that number. Okay, so let's say the first iteration what I do is 12 modulus 1. So this will give me 0. That means 1 is a factor. Okay, so I'll print that 1 only if the remainder is 0. If the remainder is not 0, I don't want to print that. Okay, then I get 12 modulus 2. So again I'll get 0. Okay, 12 divided by 2, 6. So 0. So I'll print the 2 as well. So 12 modulus 3, what I'll get? I'll again get 3 into 4, 12. So remainder is 0. So 12 modulus 4, again I'll get 0 because 4 into 3 is 0. 12 modulus 5, what will happen here? Here I will not get the remainder as 0. Okay, so 12 modulus 5 will be, remainder will be 2. So I will not print this number. Okay, so I will not print the 5. Then 12 modulus 6, this is equal to again 0. So 6 I will print it. 12 modulus 7. So like this, these things 7, what will happen? 5. The modulus will be 5. So this is again not a factor. Okay, like this. 12 modulus 8 will also is not a factor. 9 is also not a factor because I'm not getting the remainder as 0. 10 is also not a factor. 11 is also not a factor. But 12 will be the factor, right? 12 into 12, 12 into 1 is 12. Okay, so this is also one of the factors. So I need to print 1, 2, 3, 4, 6, and 12. Okay, so let's write the logic for that. So what I do here is so whatever number, I can take any number, right? Here I have shown the example of 12, but let me take it from the user, whatever value the user will provide. So according to that value, I should be able to print the factors. Okay, so let me take it as where num is equal to, I'll use the prompt. So the prompt is used to take user input. So enter a number. And then what I need to do is I need to run a for loop. So in the for loop, what I'll do, I'll take a variable I is equal to, so it will start from 1, right? So 1 to that number, whatever that number is. If the num value is 13, if then the loop should start from 1 till 13. Okay, so I less than equal to, what is the number? Num. It will go up to num and I plus plus. So here what do I do? Here I have to check whether the remainder is 0 or not. So I write an if statement. If num modulus 1 equal to 0, only then print the value. Okay, so console.log of what I should print, I. Okay, so if the remainder is not 0, nothing will happen. Okay, because there is no else statement, so it will only print the numbers which are the factors of the provided number. Okay, so let's save this, go to the browser and run it. So it is asking for the number. I'll put a number like 12. Let's start with 12. So I'm getting 1 2 3 4 5 6. Oh, so something is wrong. Can you see 7 8 9 10 11 12 came up to 12. So what is the problem here? Here I have written 1. Okay, I. So num mod I will be equal to 0. Okay, if I reload it now, so 1 to 12. So I'm getting 1 2 3 4 6 and 12. Let's try with some other numbers. Like 46. Okay, I got 1 2 23 and 46. Let's start with 9. So 9 is a not a what it is called. 9 is a prime number. That means it will have only 1 and 9. Oh, sorry. 9 is not a prime number. So I'll get 1, 3, and 9. Right? So I got 1, 3, and 9. Let's try a prime number. Let's say 5. So what I'll get here? I'm getting 1 and 5. If I try with 2, I'm getting 1 and 2. If I try with 10, so I should get 1, 2, 5, and 10. So I'm getting 1, 2, 5, and 10. Okay. So that is the logic for finding the all the factors of a given number. Okay, so this was the code for finding all the factors of a given number. Now let us try to find the number of factors of a given number. So let's say when I had tried for 12, I got 1, 2, 3, 4, 6, and 12. That means 12 is equal to 1, 2, 3, 4, 6, 12. So how many factors I got? 1, 2, 3, 4, 5, 6. So I should get the output as 6 if I try to find the number of factors. Okay, so what do I do for that? So the same code we need to modify a bit. Okay, so let me create a new file. Count the factors. Okay, count the factors.html. Okay, fine. So what I'll do is I'll use the same code whatever I had written for printing all factors. So what I'll do here is, so here I'm getting all the factors when I'm getting it in the if condition. If the number divided by I is giving us remainder 0, that means it is a factor, isn't it? So at this point what I have to do is I have to keep a count of the number. Whenever this if condition is satisfied, we have to count it. So first time when the if condition is satisfied, I have to say that okay, this is count number 1. Okay, that is factor number 1. So what will happen here? So let's say what I need to have here is I need to have a count where count is equal to 0 initially. Okay, so what will happen here in this if condition? So this if condition, this whole for loop will start from 1, right? So for the first time, the num modulus I equal to 0 will be satisfied. So I'll get that I can say that 1 is a factor. So that means at that time I have to make this count from 0 to 1. Okay, increment this count from 0 to 1. So 1 for the value 1, I'll get 1 in count. For value I equal to 2, next iteration I'll get count as 2. I have to increment it again. So for 3, 4, I'll increment. So up to 4, I'll get 4 factors. When the I value will be 5, the this condition will not be satisfied and we will not increment the value. So the value of count will still stay at 4. Okay. So like this, we'll get the number of factors of the given number. So let me do that. So here, count plus plus. Whenever the condition is satisfied, I have to increment the count. And here I'll not print the I. I don't want to print the number. I don't want to print the factor. I want to print the count of the numbers. Okay, and I'll not print it inside this for loop. What will happen if I when I write a line inside the for loop, it gets repeated again and again. So I don't want to repeat any printing. What I want to do is, after the for loop is completed, I just want the count of factors. I just want the number of factors. Okay. So in this loop, when this number I value will start from 1 and it will go up to num, the number of factors will be stored in the count variable. Okay. After the for loop is complete, I can just print the value of count so that I can get the number of factors. So console.log of count. So what will happen here? So let's say, let me take a small variable like 4. So what will happen? For the first time, it will do 4 modulus 1. So this is 0. Okay, 4 modulus 1, 0. So count value will become 1. Okay, next time 4 modulus 2. So this is again equal to 0. So count will be incremented to 2. Then 4 modulus 3. So this is not equal to 0. This is 1, isn't it? So count will not be changed because count increment value is inside the if condition, isn't it? So when the modulus will be 1, so this whole if block will not work. So count will still be at 2. Okay. Next time 4 modulus 4. So what will this give us? This will again give the remainder as 0 and count will be incremented to 3. Okay, because the condition is satisfied. Okay, so at the end of all this thing, when I print the when I do the console.log of count, I'll get the count as 3. So that means 4 has 3 factors. What are those factors? 1, 2 and 4. Okay, so that is the logic. So let's try this, save it, go to the browser to count the factors. So let me take a number. So I'll start with 4. I'm getting the count as 3. Okay, then let me take 12. I should get 6, right? So I'm getting 6. So like this, if you take bigger numbers like 48, we'll get 10. Okay, like this we can count the number of factors of a given number. Okay, this time we'll try to determine, we'll try to find out whether a given number is a prime number or not. Okay, so what are prime numbers? Let's say we have 2, we have 3, we have 5, we have 7, we have 11, we have 13, we have 17, we have 19. Okay, so what is common in these numbers? Why do we call them prime numbers? Prime numbers are those numbers which have only 2 factors, that is 1 and the number itself. Okay, so 2 equal to 1 into 2. There is no other factor of 2. In the same way, this 3 is also having only 2 factors, that is 1 into 1 and 3. Okay, in the same way 5 is having 1 and 5, 7 is having 1 and 7, 11 is having 1 and 11, 13 is having 1 and 13, 17 is having 1 and 17, and 19 is also 1 and 19. Okay, so that means if we can find out that we can find the number of factors, if the number of factors of a given number is 2, then that means it is a prime number. Okay, so till now we have already seen that how to find the number of factors, isn't it? This was the count the factors.html. So in this file we have found out how many factors are there. So if this count value is 2, if it is not more than 2, that means that is a prime number. Okay, so let's do that. I'll copy this code, create a new file, prime or not. Okay, I'll name it as like this. So here I'll just paste the code. So this code, what is this code doing? This is taking a number from the user. It is trying to find the number of factors and it is printing the number of factors. But here we need to change a bit. What we need to do, I don't want to print the number of factors. At this point, I have the number of factors because the count is incremented, isn't it? From 1 to the given number. So we have checked and we have got the number of factors. Now, here what I have to check is if the count is equal to 2, That means if the number of factors is 2, that means what? That means it is a prime number. Okay, so I'll just write console.log of it is a prime number. Okay, and if the number of factors is not 2, then we just need to write an else condition. Here I'll write console.log of. So if it is having not if it is not having 2 factors, that means it is not a prime number. Okay, so it is not a prime number. Okay, that's it. Here we already had the count. We just need to check what is the count value. If the count value is 2, that means it is a prime number. If it is not 2, then it is not a prime number. Okay, save this, run the file, and let me put some number. Let's say I put 5. So I am getting it is a prime number. If I put 6, so 6 means 1, 2, 3, and 6. So that there are 4 factors. So it will say that it is not a prime number. Okay, so like this, if we put 23, I'm getting it is a prime number. When I'm putting 91, I'm getting it is not a prime number. If I put 97, I'm getting it is a prime number. Okay, when I put 100, it is not a prime number. When I put 101, I'm getting it is a prime number. Okay, I hope that is clear. So this is how we find the find whether a number is a prime number or not. Okay, this time we'll try to print all the digits of a given number. Okay, so what does that mean? Let's say we have a number like 3, 4, 5, 6, 7. Okay, so what I want to do is I want to print 3, 4, 5, 6, 7. That means I want to separate all the digits. Okay, it may be in any order, but I want the digits. What do I do for that? So to do that, what we need to do is we need to know how to separate each digit. Okay, so let me create a file. Print all digits.html. Okay, so here let me take a number where num is equal to 365. So how do I separate the digits here? So before doing that, we need to know some basic operations in JavaScript. Let's say we have the percent operator, that is the remainder operator. So using that, we can do a lot of things. Let me show you something. Like let's say we have a number 1, 2, 3. If I try to find the remainder of when I divide this number by 10, that means 1, 2, 3% 10. What do I get? 1, 2, 3 divided by 10 will give you, the remainder will be 3, because 12 into 10 plus 3, that is equal to 123, isn't it? So when I divide the number by 10, I get the remainder as 3. So 3 is nothing but the last digit of 1, 2, 3. Let's say we have another number like 960 or 964. Okay, so if I do 964% 10, what I'll get? I'll get the last number, that is 4, because 960 plus 4, that means 96 into 10 plus 4. Okay, so that means whenever I write %10, that means if I try to find the remainder when divided by 10, I always get the last digit. Okay, that is one thing. And one more thing we need to know, that let's say I have a number that is not a whole number, that is an integer. Let's say 12.3 or 12.5. Okay, so here if I apply parse int of 12.5, what do I get? I get the answer as 12, because parse int will remove the decimal part of the given number. Okay, decimal part of the number that we provided to the parse-in function. Okay, so these are the two things we need to know to print all the digits of a given number. So let's see how do we use these two techniques to find the to print all the digits of this given number. Okay, so what I'll do is let me do something like this. Num modulus 10. What I'll get from this? Num mod 10 will give us 5, right? Then I got the one of the digit, right? Now what I can do is this num, if I divide it by 10, what I will get? I'll get 36.5. But if we apply parse into this num by 10, that means 36.5. Parse into 36.5 will give us 36 because it will remove the decimal part. 36.5 from 36.5 it will so let me write it like this here. Parse into 36.5 and this will give us 36. Okay, now we have 36. Again that 36 to that 36, if I apply 36, now I'll repeat the same things again. 36 modulus 36% 10. What this will give me? It will give me 6. Okay, then so I have got 5, I have got 6. Okay, two digits are already separate. Here I do the parse int again. So parse int of 36 by 10. Okay, remember what I'm doing. Whatever number I'm using here for the module for the percent operator, same number I'm using it for this parse int of num by 10. Here again I use 36% 10, so I'm using 36 by 10. Okay, so what will this give us? Parse int of 36 by 10 means 3.6. Okay, so this will give me 3. Okay, now so I've got 5, I've got 6, and I've got 3, isn't it? So that means we have separated all the 3 digits from 365. So if I at this point if I print this value, I am getting 5. At this point if I print this value, I am getting 6. And at this point if I print this 3, this value, I am getting the 3. So that means our operation is complete. Okay, so this is the logic we need to use for finding the all the digits of the given number. So let us put it in a loop. Okay, so I'll use a while loop. So in the while loop, what should be the condition? If you see, what I did earlier was this num, I used it here, and at this point whatever number I got, that number only I applied the modulus 10, right? So here if I apply the percent 10 to this 3 again, what will happen? 3% 10, this will give me what? 3 divided by 10 is 10 into 0 plus 3. That means the remainder is 3, isn't it? So at this point we can print the value and get it 3. So where we need to print the values, we need to print it here, and here. So whenever we are doing the percent 10 operation, at that points we have to print the value so that we can get the digit. So here we are getting 3, here we are getting 6, here we are getting 5. Okay, so this parsing part, if you repeat again here, so parse int of, so recall again what number we were doing the parse int of num by 10. Whatever value we were doing percent 10, that number only we were doing by 10. 36 mod 10 percent 10 was there, so I wrote 36 by 10. So here 3 was there, so I'll write 3 by 10. Okay, 3 by 10. So what will happen here? 3 by 10 means 0.3, and parse int of 0.3 will give you what? 0. Parse int of 3 by 10 means 0.3. So this will give me, it will remove the decimal part and it will give us 0. So at this point I can stop actually, because I have already got the 3 digits. So that means, when do I need to stop the loop? Whenever this value is getting to 0, whenever this value is turning into 0, at that point I have to stop the loop. Okay, so let me move this part from here to here for now, and let me write the loop. Okay, so what I'll do, while, let's say I so let's say this value, and this value is num. Okay, with this num value, let me put it here. Whenever num is greater than 0, it will run up to that point. Whenever it is 0, it will stop. Okay, so here what do I write? I write so I need a remainder here. To find this a remainder, to print this value, I need a remainder. So where rem, I write it like this. So here rem is equal to num mod num percent 10. This is what I did here, right? After doing that, immediately I have to print, right? Because I'll get the last digit. So I'll do console.log of rem, or I can make it as, instead of rem, I can make it as digit. So it will print the digit, isn't it? So digit, so console.log of digit. Okay, okay, fine. Now after that thing, what I need to do after printing, I need to do this parse int of num by 10. What is the num here? Num is this number. So parse int of num by 10. So this value, I'll put it here. Num is equal to parse int of num by 10. What will happen here? See, first it was 365. Now check this condition. Num is greater than 0. Yes, 365 is greater than 0. Digit equal to num mod 10. So digit will have the value 5, last digit. Then we'll print the 5. Then num equal to parse int of num by 10. What is num? 365. 365 by 10 is 36.5. So 36.5 parse int will be 36. So in num, 36 will be stored, just like this. Whatever we did here, 36 was being stored here. Okay, so I'm making it as num. Next time what will happen? In num, instead of 36, 3 will be stored. At the end, in num, 0 will be stored, as shown here. I have already shown it here. So when the num will become 0, at that point what will happen? It will try to go to this loop, and when it will check for this condition, it will fail. So it will stop there. Okay, it will go only up to there. So we'll, in this way, we will get in this, for this, because of this line, we will get for 5, then 6, then 3. Okay, let me run this code. So but we didn't print it. Okay, okay, we have already printed here. Okay, fine. So that means we are getting all the values. Okay, let's save this. So print all digits. Okay, so here I'm getting 563 Okay, so instead of doing this, what we can do is we can put a prompt here to get any kind of value, any number we enter. So enter a number. So whatever number I put, it will print the value. So let's say 1546798 I'm taking a big number. So I'm getting all the numbers 1546987. So let's say 123456. So I'm getting 123456. Okay, all the digits I'm getting. Let's take another number 3867934. So I'm getting 367934. So all the digits I am getting. Okay, so this is how we separate all the digits of a given number. Okay, so we have seen how to separate all the digits of a given number. Now we'll try to do something different. What we'll try to do is we'll try to print only the even digits of a given number. Okay, so let's say I have a number 1 2 3 4 5 6. So what output I want? I want to print only 2, 4 and 6. Okay, I don't want to print the odd numbers. Okay, so let's try to do that. So the same code we need to modify a bit. Okay, so let me create a number file, print only even digits .html. So here print all digits from this, and just copy the code and paste it here. Okay, so now, so when we are doing this console.log of digit, at this point what we are doing, we are separating the last digit and we are printing. So while separating the last digit, we should check whether the number, whether the digit is even or not. If it is not even, if it is odd, we don't need to print it. Okay, so here we got the digit, last digit. So at this point what I'll do is I'll write an if condition. So if digit is, if digit %2 equal to 0, only then print the value. Okay, that means this line I'll paste it here. Okay, and this part should be outside of the if condition. Why? Because if I put this inside the if condition, this line will not be executed if the digit is odd. Okay, but this part is needed, because if you see carefully, at this point what is happening, let's say we have a number called 354. Okay, what will happen? For the first time, this console.log of digit will print 4. Okay, and then it will do this part. What will this part do? Num is 354. 354 by 10 is 35.4, and % of 35.4 will give you 35. Okay, fine. Now in the next time, what will happen? This 35 will be divided by 10 to get the remainder. So 35 mod 10 will give you 5 in digit. So here digit of modulus 2 will not be equal to 0. 5 mod 2 is not equal to 0. So if I put this line inside the if condition, this line will not be executed. But this line is very important, because this 35 by 10, % of 35 by 10 will give you 3. So this line is actually separating the last digit. So if we write it inside the if condition, it will not separate the last digit. So we will not get 3. First time when we are getting 4, we are able to get the 35, but when we will get 5, it is not an even number, so it will, and if I put this line here, it will not do the 35 by 10, % of 35 by 10. So we will not be able to separate the 3 from the whole number. Okay, will not be able to separate 3 from 3.5. So that's why this part should be outside. So let me run this code and show you. So let's take a 3-digit number first. Okay, so where is that? Print only even digits. Okay, so let me take 354. Okay, so when I print on this, I'm getting 4, because 3 and 5 are odd numbers. So that's why it is working fine. Now let me take another number. Let's say 256. So what will be the output? I will get 2 and 6, right? So I'm getting 2 and 6. But what will happen if I put this inside the if condition? This will not be able to go to the 2. Okay, so I write again 256. I'll get only 6. Okay, because it is not able to go to the 2 and 5. Okay, that's why we need this line outside. Okay, I hope you got it. That's it. This is how we print only the even digits of a given number. And also, if you want to print the odd digits of a given number, you just do this. Whenever the remainder is not 0, that means if it is odd, only then print it, otherwise don't print. So let's see this as well. So if I write here, okay, Let me run it again. Print only even digits. Okay. So here if I write 3, 5, 6, I'll get 3 and 5. I'm not getting the 6 because 6 is an even number. Okay. Okay. I hope you got it. So we have seen how to print all the digits of a given number, right? So now I'll try to do something different. Instead of printing each digit, we'll try to count each digit so that we can get how many digits are there in a given number. Okay. So for that, what do we do? So for that, we need a count variable which will have a record of the count of the number of digits. So initially the count value is 0. Okay. So at this point, whenever this we are getting this digit equal to num mod 10, at this point we are getting the last digit every time, right? So at this point, instead of printing the digit, what you need to do is you need to increment the count. Okay. So after this whole loop is complete, what will happen initially? So if I put 354, first when 354, let's say 354. So initially when 4 will be taken by this digit, count will be incremented to 1. When 5 will be taken, count will be incremented to 2, and 3 will be taken at that time, count will be incremented to 3. Okay, after that the loop will complete, isn't it? So count will contain 3. That means if we print the count console.log of count, we can get the number of the digits, because ultimately the total number of digits will be stored there, right? So what we do is okay, so that is the thing. So let me create a new file and put the thing. Okay, so count all digits of HTML. So print all digits. Just I'll copy this, paste it here, and I'll change the code where count is equal to 0 initially. Instead of this, count plus plus, and after that I just need to print the count value. Okay. Okay, let's save this and run this thing, count all digits. So let's say I put 1, 2, 3. I'm getting 3. Let's say I put 3, 7, 9, 4, 2, 0. So that means 1, 2, 3, 4, 5, 6. So I'm getting 6. So let's say 3, 5, 4. I'm getting 3. Okay, that's it. That's how we can count the number of digits in a given number. Okay. So we have seen how to count the number of digits in a given number. Now let us see another scenario where let's say I have a number something like this: 131 451 213 671. Okay, so in this number suppose I want to count the number of ones present. So this is an 1, this is another one, this is another one, this is another one, this is another one. And so I have totally 1, 2, 3, 4, 5. 5 ones are there. 5 ones are there. Okay. So that means I want to count the number of digits which are 1. Okay. I only want only the ones, not the 3, 6, 7, 2, 4, 5. I don't want those things. So I want to count how many ones are there. So what do I do for that? Here we are already counting each digit. So instead of counting each digit, I just want to count only the one. So for each digit, I am doing count plus plus. Instead of that, what I can do is I have to check whether the digit is 1 or not. So if digit equal to 1, only then increment the count. Otherwise, don't increment the count. Okay. like this, and this will always be outside the if condition. Okay, so here what will happen is if the digit is 1, only then the count will be increment. Okay, so let's check this. I've saved it and run this. Where is this file? Yeah, count all digits. Okay, I didn't create a new file, so I'll create a new file. Okay, so just copy this, create a new file, count all ones. .html, just paste it, and here I'll write the if condition. Digit equal to 1. Cut this line, paste it here, and yeah, that's it. Okay, so count all ones. If I put here 1 3 1 2 4 1 5 1 6 1, so how many ones are there? 1 2 3 4 5, so I should get 5, so I'm getting 5 here. Okay, let me reload. 1 0 1, I should get 2, right? 2 ones are there, I'm getting 2. Let's say I write 1 1 1 1, I should get 4, so I'm getting 4 ones. Okay, so that's how we can count the number of ones in a given number. So this way you can count any number. Let's say you want to count how many 2 are there, how many 3 are there, so you just need to replace it here. If you write 3, it will count the number of 3. It will, if you write 8, it will count the number of 8. That's it. Okay, okay, fine. I hope you got it. This time we'll take a given number and we'll try to print only the digits which are less than 5. Okay, so this is the code for printing all the digits of a number. So we'll just modify this. I'll take this code and paste it in another file. So here what we were doing, this line console.log of digit was the last digit, so we were printing the all the digits, right? So but we have a condition here. What is the condition? If the digit is less than 5, only then print it. Okay, so cut this code and paste it here. So what will happen? So it will print the digit only when it is less than 5, otherwise it will not be printed. Okay, so that's it. That is enough. So let's run this code. Print digit less than 5. Okay, so let me put something like 1 2 3 4 5. So I should get 1 2 3 4. I'm getting 1 2 3 4. Let's say I write 5 6 7 8 2 9 0. So what I should get? I should get only 2 and 0. I should not get 5 6 7 8 9. So I'm getting 2 and 0. Okay, take another one. 1 3 5 7 9 2. So I should get 1 3 and 2. Okay, I got 1 3 and 2. So I hope you get it. So this is how we print only the digits which are less than 5. Okay, so now let's try to solve a problem. So we'll try to check whether a number is an Armstrong number or not. So the first question is, what is an Armstrong number? Okay, so let's see. An example of an Armstrong number is 153. Okay, so how do we check that? What we can do here is, how many digits are there here? Here there are 3 digits. So if I separate all the digits, what are the digits? I have 1, I have 5, and then I have 3, isn't it? So 1 to the power, 1 raised to the power, how many digits? 3 digits. 1 to the power 3 plus 5 to the power 3. All the digits should be raised to the power of the number of digits. So 1 to the power 3 plus 5 to the power 3 plus 3 to the power 3. Okay, here 1, 5 and 3 are the different digits of the number, and this 3 is this power 3 is the number of digits. 3 digits are there, that's why I'm doing power 3. So how much this will be? Usually 1 to the power 3 is 1 plus 5 to the power 3 is 5 to 125. Okay, plus 3 to the power 3 is 27. So how much do I get? This all sum, if we add these three numbers, we will get 153. So if this 153 is equal to the original number, that means 153 is an Armstrong number. That is the definition of Armstrong number. Let's see some more examples of Armstrong number in Google. Let's say Armstrong number. So we have 9474. Here you can see 9 to the power. So there are 4 digits. So all the digits are raised to the power 4. 9 to the power 4 plus 4 to the power 4 plus 7 to the power 4 plus 4 to the power 4. This is giving us 6561 plus 256 plus 2401 plus 256, which is equal to 9474. Indeed, which is equal to the original number. That's why 9474 is an Armstrong number. Again, you can see here 1634. This is a 4-digit Armstrong number. 4 digits are there, that's why 1 to the power 4 plus 6 to the power 4 plus 3 to the power 4 plus 4 to the power 4 equal to 1634. Okay, so this is 4-digit Armstrong number. Okay, we can even check for 5-digit Armstrong number. You can just search it like this, 5-digit Armstrong number. So you will get a 5-digit Armstrong number as well. Yeah, you can get here 54748 92727 93084. Okay, these are all 5-digit numbers. So like that, we have 6-digit numbers, we have 7-digit numbers, like this. Okay, this is 3-digit, these are 4-digit, this is 5-digit, these are 6-digit, like this. So many numbers are there. So we need to write a code to check all these numbers whether these are Armstrong number or not. Okay, okay, so for that, what are the things we need? First thing is we need to separate the digits 1, 5 and 3. And second thing is we need to know how many digits are there in this number so that we can raise it to the power. So if 4 digits are there, we have to raise the digits to the power 4. I have to write 1 to the power 4 if there are 4 digits. If there are 3 digits, I have to do power 3. Okay, so this question is actually divided into 2 parts. First thing is we need to know the number of digits. Second thing is we need to know the separate digits. What are the digits? Okay, so actually we have already done here. Let me show you. So we had a program for count all digits. So this was the code that we use for counting the digits. So if we know the number of digits, we can use that for the power. Okay, so I'll use this code and I'll paste it here in the beginning. So what will this give us? This will give us the number of digits. So console.log of count. So we don't need to console.log. We have the number of digits in the count variable. That is fine. Okay. Now what is the next thing we need to do? Now next thing we need to do is we have to separate the digits. Okay. So for separating the digits, we had to print all digits code. So this code we can reuse in our Armstrong number. So here I'll paste it. So this is one part. This is for finding the number of digits, and this part is for separating all the digits. Okay, that's fine. Now we have the number of digits, we are separating the digits. Now we have to, in this separating the digit, we don't need to print each digit, right? What we need to do is instead we have to find the sum. So for example, let's take a 4-digit number. So let's say I have or let's say we will start with the simpler one, 153. Okay, fine. So we have the let me write it here, 153. Okay, so this we have to break it into 1 to the power. So first we know that there are 3 digits, so here in the count we got the count as 3, that is fine. Now here we have 1, 5 and 3 in this. Okay, so each digit is 1, 5 and each digit is in the digit variable. Okay, that's fine. Now what we need to do here is, there is a problem here. Here we are using the var num equal to this, and then this num value in the beginning, it is getting smaller and smaller, and in the first case it is 153. At this point it has become 15, isn't it? Because parsing of num by 10 will give you 15.3, and parsing, if we apply, it will give us 15. The next time it is becoming 1, and at the end it is becoming 0. The moment it is becoming num is becoming 0, this loop is closed. Okay, so we can't use the num here again. Okay, so instead what we will do is, we'll take another variable. Let's say var temp. Okay, where temp is equal to num. So what will happen? This num will be stored in temp. So this temp we can use here. So we can remove this prompt. We don't need to prompt it again. We have already saved the num in temp, so we can use it here. So here instead of num we can use temp, because num will not have the value. Num has already become 0 in this part. Okay, so wherever there is num, we'll replace it with temp. So here also temp, and here also temp. Okay, fine. So in temp, actually what is there, whatever prompt, in the prompt we gave the number, that is 153, that 153 will come here and it will be checked here. Now this digit value, digit is also repeated here, isn't it? We are using it again. So here the digit value, we are not using it for anything. Okay, so we can use this, reuse this variable, no problem. So we can use the same digit variable what we used here, because this digit, first time it is having 3, next time it is having 5, then it is having 1. Okay, so that is not a problem. So here we can again reassign it and put the 3, 5 and 1 again, so that won't cause a problem. Okay, so we can use the same digit variable. Okay, fine. Now that is done. Here what we have done, here we have found out the number of digits, and here instead of printing each digit, what we need to do is, we have to find the sum of these things. That means 1 to the power 3, because it is 3 digits, plus 5 to the power 3, plus 3 to the power 3. This calculation we need to do it here. So this is a sum, so we have to find the sum of all these numbers. So what I'll do is, I'll take a sum variable in the beginning, where sum is equal to 0. Okay, and here instead of doing console.log, I will write sum is equal to sum plus what I will do, sum plus digit. This is the digit, each digit we are having it here. So digit to the power, raised to the power what? The number of digits. So the number of digits we have in count. So I can put here count. Okay, sum plus digit to the power count. That is fine. So if you print the value here, console.log of sum, you will get the sum of all the digits. So let me check this. Go to the browser and reload it. So let's say if I put here 153 and I press OK, I'm getting 153. If I put some other value like 123, I'll not get 123. I'm getting 36. So 123, what is happening? 1 to the power 3, that is 1, plus 2 to the power 3 is 8, plus 3 to the power 3 is 27. So 27 plus 8 plus 1, how much? 27 plus 8 is 35, 35 plus 1 is 36. That's why I'm getting 36. So that means it is not an Armstrong number. Only if the sum is equal to the original number, then only then we can say that it is an Armstrong number. So what we do? So we have the sum here, but we don't have the original number here. We don't have the original number anywhere, because the original number was initially stored in num, but the num got decreased one by one, and at one time num got changed to 0. So num is not having the original value. Again, we stored the num in temp, but even here, if you observe carefully, the temp is also becoming 0 at some point. Temp, we are doing parsing of temp by 10. Initially it is 153, then it is becoming 15, then it is becoming 1, and then it is becoming 0, at which point when it is becoming 0, this loop is stopping. So we don't have the original value anywhere. So we can take another temporary variable where we will store it. Let's say where arm is equal to num. So what is num? So num, whenever we are getting it from the form prompt, we are storing it in two variables, one in temp, one in arm. Okay, original is in num, next time it is going to temp and also to arm. So num is becoming 0 here, temp is becoming 0 here, but arm is not changed. So arm, in the arm, original num value will be there. So here what we can do is, here we can check the value of, so original value is, what was it? Original value is stored in arm. So if arm, sorry, if arm is equal to what? The sum, because sum is containing 153, right? If arm is equal to sum, then we can say that what we can say? We can say that it is an Armstrong number. Okay. Else, if arm is not equal to sum, then we can say that console.log of it is not an Armstrong number. Okay. So what is sum? Sum is having 1 cube plus 5 cube plus 3 cube, and arm is having the original number. So if the original number is equal to the sum, that means it is an Armstrong number, otherwise it is not an Armstrong. So let's check this. I have saved this, go to the browser and reload. So we'll check one by one. What are the values we have? I have 153. Okay, I'll put 153 and press OK. I'm getting it is an Armstrong number. Okay, I can put 370. So I'll put 370. 370. Get it is an Armstrong number. Then I can put this 4-digit number 1634. So let me put 1634. Press OK. I'm getting it is an Armstrong number. Let me put a non-Armstrong number, which is not an Armstrong number, like 1635. What will happen here? It is not an Armstrong number. Let's say I write 1 2 3 4 5 6. 1 2 3 3 4 5 6. I wrote something like this. I'm getting it is not an Armstrong number. Let's see. So this is 548834. This is a 6-digit Armstrong number. Let me check this. 548834. Okay, it is saying it is an Armstrong number. So I think that is clear. Let me check a 9-digit number. 9-digit Armstrong number. So if I paste this, I am getting it is an Armstrong. I hope it is clear. So this program is able to check whether a number is an Armstrong number or not. So here, check whether it is an Armstrong number. So we are having 3 parts. First part, what we are doing, we are finding the number of digits. The second part, we are separating the digits, and in the third part, separating all the digits, and also we are finding the sum of the powers, isn't it? 1 to the power 3 plus 5 to the power 3 plus 3 to the power 3, according to the number of digits. Okay, and then we are checking it here, and we are getting the output, whether it is Armstrong number or not. I hope that is clear. So this is how we can find whether a number is Armstrong number or not. Okay, this time what we will try to do is, here we will try to print the digit at 10th place of a number. So we have seen till now that how to print the last digit of a number. Let's say I have a number called 6764. So in order to print the last digit, what we did was we just used the remainder operator, and we wrote 760% 10, and this gave us the last digit. That is, when a number is divided by 10, the remainder is the last digit of the number. So this gives us 4, isn't it? But here now we want to do something different. What we want is we want to get the tens place, the digit at the tens place. So let's say this is a big digit. 7 is known as the units place. 7 is the digit at the units place. 4 is the digit at tens place. 3 is the digit at hundreds place. 8 is the digit at thousands place. 7 is the digit at 10,000 place, like that. 4 is the digit at 100,000 place. 8 is the digit at 1 millionth place. 3 is the digit at 10 millionth place. Okay, so if you take a small number like 1 2 3 4, this is actually equal to 1 into 10,000 plus 2 into 1 into 1000 plus 2 into 100 plus 3 into 10 plus 4 into 1, isn't it? This can be further broken down into 1 into 10 to the power 3 plus 2 into 10 to the power 2 plus 3 into 10 to the power 1 plus 4 into 10 to the power 0. Okay, 10 to the power 0 is equal to 1, so 4 into 1. 10 to the power 1 is 10, so 3 into 10. 10 to the power 2 is 100, so 2 into 100. And 10 to the power 3 means 1000, so 1 into 1000. So this whole thing, when we add, we get 1 2 3 4, that's 1234. Okay, so this is the basic thing we need to know for finding a digit at tens place, hundreds place, anything. Okay, so now I will tell you the logic behind what we are going to do to find the digit at tens place. Okay, so so this question is actually in this example, I don't not only want to show you how to find the digit at tens place, but I want to show you how to find the digit at nth place. That means at any place. Like if you want to find a digit at units place, what you will do. If it is at tens place, what to do. If it is at hundreds place, what to do. And if it is 10,000 place, what to do. Whatever be the condition, how to find out the digit. Okay, so let's start. So let's say we have a number where num is equal to, let's say we'll take a big number 35897023. Okay, let's take this number. Okay, now we know this part, whatever we have written here, isn't it? So now what we need to do here is first let me talk about the units place. So for the units place, you don't need to do anything. You don't need any loops or anything. Okay, just num mod 10 will give us the units place. That's it. Okay, but we'll not do it in that way. Whatever we will try to find out, let's say units place, tens place, or hundreds place, or thousand place, 10,000 place, whatever we want to find out, we'll find according to this theory. Okay, whatever we have written here, we'll try to find out the value according to this theory. Okay, so for the units place, I'll leave it for now. I'll come back to the units place after some time, after explaining what happens in the tens place, hundreds place. Okay, so now let us try to find out the number at the tens place. So how do I find the number at the tens place? What I can do, first thing is I can do something like Let's say I do parse int of what? Num by 10. What I will get if I do parse int of num by 10? I will get this whole number divided by 10 will give you 3589702.3, isn't it? 3589702.3. Okay, this is num by 10. So if I apply parse int, this 0.3 will be removed and I will get this number. Okay, on this number, if you apply mod 10, what will happen? You will get 2, isn't it? And the 2 is the tens place of this number, isn't it? So this way you can get it. First we have to find out parse int of num by 10. So let's say I write here where x is equal to parse int of num by 10. In the next line, what I write is x mod 10. So let's say where y is equal to x mod 10. So in this y we will have the 10th place. Okay, so for any number, if you want to find out the 10th place, you will do this, isn't it? So this is only one time, but if you want to get the hundredth place, you have to repeat this again and again. This parse int of num by 10 you got here. So let me separate this line for the time being. This part I'll separate for the time being. Okay, so here what you got? You got, when I did parse int of num by 10, I got 3589702.3. When we apply the parse int, this 3 is gone, 0.3 is gone, so I get this. If I want to get this hundredth place, what I have to do? I have to apply this line again. Okay, like this. So what will happen this time? Parse int of x, let's say x by 10. In x, this value was there. This whole value by 10 will give you 358,970.2. Okay, so if we apply parse int, 0.2 will be gone. So we will have 358970. Okay, 358970. When I do mod 10, where y equal to x mod 10, what will happen? It will give us the last digit. So this way you will get 0. It is the hundredth digit, hundredth place. That is the digit at hundredth place you will find by doing this part. So we are repeating this 2 times, isn't it? If you see carefully, 2 means, that is 10th place means 10 to the power 1. So for that we need to do parse int 1 time. For 100th place, the digit at 100th place, that means, if you see, 100 means 10 to the power 2. So for 10 to the power 2, to find the 100th place digit, we have to do parse int 2 times. So whatever is the power, we have to do that number of times the parse int. Okay, parse int, if you do 3 times, you will get the 1000th digit, 1000th place, the number at 1000th place, the digit at 1000th place. If you do the parse int 4 times, you will get the digit at 10,000th place. Okay, 10,000th place, what is the digit? 9. So if you do parse int 3 times, 4 times, you will get this one. Okay, 1, 2, 3 and 4. Okay, so to get the last digit, what is this digit? Ones, tens, 100, 1000, 10,000, 100,000, 1 million, 10 million. So if you want a 10 millionth digit here, how many times you have to do the parse int? 1, 2, 3, 4, 5, 6, 7. 7 times. Okay, so that means 10 to the power 7. Okay, so that is the logic behind what we need to do here. Okay, so for that, what we need to do is to find out, to have the number. So we will take one variable here where I is equal to 1. Okay, I took one variable I and I have to loop all these things, isn't it? So what I'll do here is I'll take for the time being I'll take a while loop. So while I is, so let's say how many times you want to do. Suppose you want to find the tens digit number at tens place. Okay, that means 2. So if you want to find the number at tens place, what you have to do, the loop should be run only once, isn't it? So I can write here I less than or equal to 1. So if I write like this, it will run only one time. So I value is because already it is 1. So it will only run one time and then it will stop. But to stop the, that means we have to first increase the value of I, isn't it? So what we can do here, we have to increment the value after doing the parseint. Immediately I have to increment the value of I. Okay, so here what will happen, already the I value is 1 and we want the tens digit, tens place, digit at tens place. So what will happen, I less than or equal to 1. So that means only one time we have to do, because tens place means what, 10 to the power 1. That means only one time we have to do the parseint. So I less than equal to 1, we'll put it as 1 so that the while loop will run only once. After executing this line, it will increment the value of I will become 2 and it will stop the loop. After that we will do this part. Okay, where y equal to x mod 10. So here what will happen, we'll get the last digit, that means this 2. Okay, after doing parts into one part is already gone. So I'll change the variable names. I don't want to write here x. What I'll write here is directly I can write the num, whatever was here. Okay, so num is equal to parse of num by 10, and here y, instead of y, here also I can use the num variable, because that num is not useful after that, right? So we can use the same variable. Okay, at this point you can see when num equal to a big number, I equal to 1, while I less than equal to 1, num equal to percent of num by 10. So the num value has changed. So now it has become this, because it has removed this 0.3 part. Num is coming here. So num equal to num mod 10. When I do, what will happen, this whole number modulus 10 will give you 2. Okay, that is the 10th digit. Okay, so now let's save this. Once let us check the output. Okay, so here at this point we have to print the num, console.log of num. Okay, save it, let's run this. So what I got here, I got 2 here. Can you see, that is the tens place, digit at tens place. So here if I put I less than equal to 2, that means what will happen, this pass will run 2 times. If it run 2 times, it will give me the hundredth place digit. Okay, because 10 to the power 2, right? So hundredth place, what is there, 0 is there. Tens place 2 is there, hundredth place 0 is there. So if I save this, go to the browser and reload, I get 0 here, tens place. If you want hundredth place, sorry, 1000th place, that means 1000 means 10 to the power 3. That means percent we have to run 3 times. So I less than equal to 3. If you write here, save it, go to the browser, reload it, you can get 7. Why 7? Because 7 is at the thousandth place. Okay, so this way, if you put 4 here, so what value you should get, you should get 9, right? So reload the page and I got 9 here. If I put 5, I'll get 8. I got 8 here, and so on. You will get 5, 3, everything. Okay, like that. Now what about the first digit? First digit was 10 to the power 0. Just try to put here 0. What will happen? See, the I value was initially 1. Now it is asking while I less than or equal to 0, but it is not less than or equal to 0. Okay, so what is happening, this whole part will not be executed because I value is 1, the condition is not satisfied. Okay, and why did we put here 0? Because 0 means 10 to the power 0, that is the unit place. So this whole part will not execute. Immediately it will come to this part, and num mod 10 will immediately directly give you the last digit 3, because the num value is whole digit, whole number, whatever we have it, the original number. num mod 10 will give you the last digit, and hence we can see that if it is 10 to the power 0, that means if you put this 0, we'll get the units place. If you put 1, you will get tens place. So like that, 0, 1, 2, 3, 4. So whatever value you put here in the while condition, i less than equal to 0 will give you units place. Just check this, you are getting 3. Okay, so that means 3 is at the units place. Okay, that's how. So here what we can do, instead of putting hard coding the number, we can put a prompt. So whatever number you put, it will give you the it will give you whatever place you want. Let's say unit place, tenth place, whatever. So enter a number. Okay, let's say I want the hundreds place. That is, hundreds place means 10 to the power 2. So I have to run the parseInt 2 times. Okay, save it, go to the browser, reload it. So I'll give a number like 9513. Okay, hundreds place means 5. I want the output 5, so I got 5 here. Okay, again I can give another now 7463. That means 4. I want 4, so I got 4 here. Okay, so that's how you can print any digit at any place. Okay, the digit at any place, that is units place, tens place, hundreds place, thousand place, using this code. Okay, and this is the logic behind it. This power 10 to the power 0, 10 to the power 1, 10 to the power 2, 10 to the power 3, and so on. Okay, so that is what the number system does. Okay, I hope it is clear. Okay, so this time what we'll be doing is we'll try to find the reverse of a number. Okay, so let's say a number, we have a number like this, 354. So what will be the reverse of this? I want the reverse to be 453, 453, 354, and we want 453. Okay, so how do we do that? So 354 is equal to 300 plus 50 plus 4. Okay, somehow we have to get the reverse, that is 453, which is equal to 400 plus 50 plus 3. Okay, somehow we have to get this. We have to convert this 300 plus 50 plus 4 into 400 into 50, 400 plus 50 plus 3. Okay, so what we will be doing here is we will separate the digits. 354, we will separate it. We already know how to separate the digits. After that, what we will do is we will keep on multiplying 10 to the digits. So if we separate the 354, what we'll get? First we'll get 3, then we'll get 5, then we'll get 4. Okay, so this 4, what we have to do to this 4, we will first multiply once 10. Okay, so what I will get? 4 into 10 will give me 40. Okay, then next time what I will do? So next time I'll do something like so to this 40, I have to apply again 40 into 10. Okay, so what I'll get? I'll get 400. In the same way, this 5 will also keep on increasing, like something like this. 5 is already at 10th place, so 5 will go into 5 into 10. Okay, it will be 50, and the last digit is 3. So 3 will not be multiplied with anything. That means 3 into actually 10 to the power 0, which is 1. Okay, so it will be 3. So here we have 400 plus 50 plus 3. So 453 will get the output. Okay, now let's see what we will do in JavaScript exactly to achieve this kind of behavior. Okay, let's see that. So first we have this number. Okay, first we have to separate the digits, isn't it? So what we'll do is we'll have one variable where rem, okay, and then we will add the digits, right? 300 plus 50 plus 4 will be converted to 400 plus 50 plus 3. So 400 plus 50 plus 3 will be stored in a sum, isn't it? Here we have to add everything. So to this sum we'll add everything. Okay, now we have to write a loop. Okay, but what we will write in the loop we'll decide later on. First let us see what are the steps we need to write. Okay, first thing is we will find the remainder, that is num mod 10. This will give us the last digit, that is 4. Now in the sum is equal to, what I will write is sum into 10 plus sum into 10 plus rem. What this will give us? Sum means it is already 0. 0 into 10 is 0 plus rem. Rem means 4. So 0 into 10 0, 0 plus 4 is 4. So in sum 4 is stored. Okay. Now after this line I will do num is equal to % of num by, why am I doing this, num by 10. What will this do? Num by 10 means 354 by 10 will be 35.4, and % if I do 35.4 will become 35. Okay, to eliminate the 4, because we have already got the 4 here, this sum will give us 4 last digit, isn't it? 0 into 10 is 0, 0 plus 4 is 4. Okay, we have already got the last digit, so we are eliminating it by using this line. Okay, so this thing here we will get 35. Again we have to repeat it from 35 mod 10 will give us 35 mod 10 will give us 5. Again in here what will happen, sum was 4, so sum into 10 will give us 4 into 10 40. 40 plus 5 will give us 45. Okay, so let me show you one by one what will happen. So just see the three values, rem, sum and num. These are the three values we need to check from the beginning. Okay, so initially num mod 10, what will happen? Num mod 10 means for the first time num is 354. 354 mod 10 will give us 4. Okay, then sum into 10 plus rem. Sum into 10, what is sum? 0. 0 into 10 is 0 plus rem. Rem is 4, so 0 plus 4 is 4, so sum will become 4. Okay, then num equal to % of num by 10. What is num? Num is already 354, it is not changed. 354 by 10 will become 35.4, where we will apply %, so 35.4 will become 35. Okay, now we will repeat this again. Again I am writing rem equal to num mod 10. What is num? Num is 35 now. 35 mod 10 will give us the last digit, that is 5. So rem will have 5. So I will remove the 4 and put 5. Okay. Now sum equal to sum into 10 plus rem. What is the value of sum? Sum was 4 initially. So 4 into 10 will be 40 plus rem. What is rem? 5. 40 plus 5 will become 45. Okay. Now what will happen to num? Num will be equal to % of num by 10. What is num? Num is till now 35. 35 by 10 will give us 3.5. So % of 3.5 is 3. Okay, we got 3 here. Now again we'll repeat rem equal to num mod 10. What is num? Num is 3. 3 mod 10 will give us again 3. Okay, 10 into 0 plus 3. So remainder is 3. So rem will have 3. Okay, I've changed it. Now sum. Sum is equal to sum into 10. What is sum? Sum is 45. 45 into 10 will be 450. 450 plus rem. 450 plus rem is 450 plus 3. 450 plus 3 is 453. Okay, then num. What is num? % of num by 10. So num is 3. 3 by 10 is 0.3. 0.3 if we apply %, it will become 0. Okay, so at this point when the num becomes 0, we have to stop the loop. That's it. Okay, so the while condition will be while num is greater than 0, we have to stop the loop. Okay, I'll just paste it here. Okay, fine. So at this point, what will happen? This sum is having the reverse of the original number. Can you see? Original number was 354. Sum is 453. So it is the reverse. So we can just console.log of sum. So this will give us the reverse of the given number. That's it. So let's now check test the number. So let me put 350. Okay, let it be 354. I should get 453. Let's save it and run it. So I got 453. Reverse I have got. So now what I'll do, I'll just put a prompt here so that we can put any number. Enter a number. Okay. Now what will happen? Whatever number we put, we can get the reverse. So let me put 1, 2, 3, 4, 5, 6, 7. Okay. If I put a big number like this, I get 7, 6, 5, 4, 3, 2, 1. Okay. Then let me put 7, 8, 9, 6. 7, 8, 9, 6 means the output should be 6, 9, 8, 7. So I got 6, 9, 8, 7. Okay. That's it. That's how we can reverse a number using JavaScript. Okay. That's it. Okay. So here we have seen how to reverse the digits of a number. Okay, we have already seen how we are using this rem, sum and num to uh, reverse the digits. Okay, now we have a new challenge, that is how to check whether a number is a palindrome number or not. Okay, so how do we check that? So let me create a file first, palindrome.html. Okay. So what is a palindrome number? 1 2 3 2 1. Okay, what will happen if we reverse the digits of this number? I'll get 1 2 3 2 1, which is the same as the original number. So if the reverse of a number is same as the original number, it is known as a palindrome number. Okay, let's say 1 2 1, it is a palindrome number. Let's say 1 2 2 1, this is also a palindrome number. Let's say 1 3 4 7 4 3 1, this is also a palindrome number. Okay, so how to detect such numbers? So we already know how to find the reverse of a number. The same code we will use to find a palindrome. So what is happening here? Here we have the original number in the num and we have the reverse of the number in the sum. Okay, so if num and sum is equal, that means the reverse of the number is also equal, and that means it is a palindrome number. Okay, but num we are changing it at so many places, isn't it? It is getting changed. So what we can do here is we can put it in a temp. Okay, temp is equal to num. So what will happen? Even if the num will change here, it will be the original number will be stored in temp. Okay, so we have the original number in temp and the reverse number in sum. So now what we can do is we can check it here. So if we have to check whether they are equal or not. So if temp is equal to sum, that means console.log of it is a palindrome number, otherwise else what we need to say that console.log of it is not a palindrome number. Okay, that's it. Save it and run this file, palindrome. So let's say give a number like 1 2 3, it will say that it is not a palindrome number. The moment we give 1 2 3 2 1, it will say that it is a palindrome number. Let's check with other numbers. 1 1 1 1 1. So this is also a palindrome number. It's a palindrome number. Now let's say 1 2 3 4 3 2 1. It is a palindrome number. 1 3 5 7 1 3 5 7 5 3 1. This is also a palindrome number. Okay. I hope that is clear. So this is how we can check whether a number is a palindrome number or not, just by modifying the original reverse of a number code. Okay. Now we will try to find the sum of all digits of a given number. So let's say we have a number like 1, 2, 3, 4, 5. Okay. So that means what should be the output? It should be 1 plus 2 plus 3 plus 4 plus 5. So this is equal to 6, 4, 10 plus 5 is 15. Okay. So that should be the output. So whatever be the digit, whatever be the number, it should the output should be the sum of all the digits. Okay. So for that, what we need to do, we have to separate the digits first, and then we have to add them. So we already have the code for separating the digits that we did like this. So we'll reuse this code here. So so in this code, what is happening? It is printing each digit. Okay. So instead of printing each digit, we have to add it. Okay. So first we'll take a variable sum, which is equal to 0 initially. Okay. So instead of this printing each value, what we need to do is we have to add the digits. So sum equal to sum plus digit, because digit in every step, in every iteration, digit will give us the last digit, last digit, last digit, like that. 354, if we have 354, first time we'll get 4, so 0 plus 4 is 4. Next time we'll get 5, so 4 plus 5 is 9. Next time we'll get 3, so 9 plus 3 is 12, like that. Okay. So after this whole loop is completed, sum will contain the sum of all the digits. So after the loop, we can print the value of sum. Okay. So now save it, go to the browser, and let's put a digit, a number 1, 2, 3, 4, 5. So what will happen? I'm getting 15. That is a correct answer. Let's say I have 578. That means 7 plus 8 is 15, 15 plus 5 is 20. I'm getting 20. Let's say 906. That means 90654. Then how much I should get? 9 plus 6 is 15, 15 plus 5 is 20, 20 plus 4 is 24. So I'm getting 24. So that is correct. So this is, I hope you got this, how to add all the digits of a given number. Now we'll try to find the greatest digit of a given number. Okay. So let's say I have a number like 540, 547. So what will be the output? The greatest digit is 7. So the output should be 7. So if I say I have 683, output should be 8. Okay, like that. So for that, what we need to do is we have to take, so let's say 683, we have to separate all the digits and then we have to compare it one by one. Every time we get one number, we have to compare it. Okay. So what will be the if that is the greater number than the previous number, we just need to check that. Okay. So first we'll take the code for the separating the digits. So this is the code. So okay, so here we were printing each digit. Instead of that, what we have to do is we have to check whether it is greater. So first we'll take a variable named greatest, and we'll put a 0 initially. Okay. So what will happen first time when the first digit will be taken? So let's say the digit is, the number is 354. First time 4 will be taken here, num mod 10. In the num mod 10, 4 will come. So in the digit 4 will be stored. Now we have to compare if this 4 is greater than greatest. If the 4 is greater than 0, then we'll put the 4 in greatest. Next time 5 will come, we'll compare the 5 with the value of greatest. So if 4 is there, 5 is greater than 4, so then again 5 will be put here. Next time 3 will come, we will compare 3 with 5. 3 is, if 3 is greater than 0, 3 is greater than 5. So 5 3 is not greater than 5, so 3 will not be put here. So what will be there in greatest? 5 will be stored. Okay, so let me write the condition. What will happen? So if digit greater than greatest, then greatest is equal to digit. Okay, that's the logic. If the digit, whatever number we are, or whatever digit we are trying to get from the number, if it is greater than the greatest, then we'll store the digit value in greatest. So after the loop is complete, we just need to write console.log of greatest. Okay, now save it and run it. So let's say I'll give a number like 483. What do I get? I get 8 because 8 is the greatest. Let me write 1, 2, 3, 4, 5, 6, 7, 8, 9. If I check this, I'll get 9. If I say a random number like this, so let me remove the 9s. Yeah, even the 8. Okay, so what will happen here? 6. I'm getting 6. Okay, so that's fine. I guess this is how we can find out the greatest digit in a given number. So now this time we'll try to convert an octal number to a decimal number. So the first question is, what is an octal number? So let's see that octal number. Okay, so what is an octal number? Octal number is a number which has a base, which is having a base 8. So if you see this 74 is a decimal number, and each place, it is said here in the decimal system, each place is a power of 10. That we have already seen. If it is 74, then we write 7 into 10 to the power 1 plus 4 into 10 to the power 0. Okay, so this is having a base 10. All the what to say, these are all powers of 10. 10 to the power 1, 10 to the power 0. So like this, 10 to the power 0, 10 to the power 1, 10 to the power 2, 3, 4, it will go like that. But in octal system, each place is a power of 8. Okay, so it is 112 base 8. How do we write this? 2 into 8 to the power 0 plus 1 into 8 to the power 1 plus 1 into 8 to the power 2. So it will go on 8 to the power 3, 8 to the power 4. So instead of 10, we have a base 8 here. Okay, now another question is, how do we convert this octal number into a decimal number? So when you calculate this thing, this part, 1 into 8 to the power 8 square plus 1 into 8 to the power 1 plus 2 into 8 to the power 0, we get the binary number, decimal number. Okay, so I'll just show you the conversion. So this is the octal to decimal conversion. Here you can see 764. So 764 is having a base 8. So what is done here? 7 into 8 square plus 6 into 8 to the power 1 plus 4 into 8 to the power 0. Remember, here we are having, instead of 10, we are having 8. Okay, after doing this, what we get? We get 448 plus 48 plus 4 is equal to 500. So 500 is a decimal number. Okay, so by doing this, what we are doing, we are converting this octal number into a decimal number. So the decimal equivalent of this octal number is 500, and we have to write here 10. So that means it is a decimal number. Okay, so this is the logic we have to use in our coding. So what they are doing here is basically 764, when they get the number, after that we have to separate the digits. So 7, 6 and 4. After that we will apply this part. So for the first digit we will do 4 into 8 to the power 0. Then second digit we will do 6 into 8 to the power 1. Third digit we will do 7 into 8 square. That is the logic we have to do. So what we need to do, we already know how to separate the digits. So we will do that first, and then we will apply the 8 to the power 0, 8 to the power 1, 8 to the power 2, and so on. Okay, so let's see that. So here, so first we'll take the code for separating all the digits. Okay, so we get it here. Now the thing is, we need to get that 8 to the power 0, 8 to the power 1, 8 to the power 2, isn't it? So for that, what I'll do is I'll take one variable where I, so that I will be is equal to 0 in the beginning, because it will start with 0, right? First 8 to the power 0, then we'll increment, for the next step we'll increment the value of I to become 1. So at that time we'll do 8 to the power 1. Next time it will become I equal to 8, I equal to 2, so we'll do 8 to the power 2, like that. Okay, so and at last we have to add all the numbers, isn't it? So for that we need a sum. So where sum is equal to 0. Okay, fine. Now inside this loop, what we are doing in this digit, we are getting the we are separating the digit, and we are getting each digit in this digit variable. Okay, fine. Now after this, instead of printing it, what we have to do is we'll do the sum. Okay, sum is equal to sum plus, initially sum is 0, so sum plus rem, whatever rem, oh, sorry, not rem, this is the digit, isn't it? We got the digit, so digit into 8 to the power 0 for the first time, that is I. Okay, so digit into 8 to the power, so at first time the value of I is 0, so I'll directly put I. Okay, that is done. After that, immediately what we have to do is we have to increment the value of I. Okay, I plus plus. So in the next time, what will happen? Or you can increase it at the end also. This is not a problem. Okay, so after the num, so at this point they are separating the last digit. We are separating the last digit, so that line is necessary. After that, you can increment the I. Okay, so this way it will go on. And what will happen? So let's say we have a small number, let's say 1 2 3. Okay, what will happen for 1 2 3? Let us see. The first time the digit value will be, so I'll write the three values: digit, sum, and we have the num. Okay, fine. So in the digit, first time what will come? First time 3 will come, so we'll have 3 here. In the sum, what will be there? Sum plus, that is 0 plus digit. What is digit? 3. 3 into 8 to the power I. What is I? 8 to the power 0. So 8 to the power 0 is 1. So 3 into 0 plus 3 into 1. So this will give me how much? 3 into 1 is 3. Okay. Then what we have? The num. Num what we'll get? Num equal to parse into num by 10. So what was num initially? Num was 1 2 3. So 1 2 3 by 10 is 12.3. Parse into 12.3 will be 12. Okay. Now after that, again the digit will be changed, because num is still greater than 0. Okay. So digit equal to num mod 10. So what is digit? 12. 12 mod 10 will give you 2. Here 2 will come. And sum will be sum plus, what is sum? The sum is already 3. So 3 plus digit into 8 to the power 1. What is digit? Digit is 2 into 8 to the power I. What is I? I is 1, because I got incremented last time. So I forgot to write the I here. Okay, I is equal to 1, because it got incremented last time. So 3 plus 2 into 8 to the power 1. 8 to the power 1 is 8. Okay, so 2 into 8 is 16. 16 plus 3 is 19. So I'll have here 19. Okay, then what about num? Num is parse into num by 10. Initially num was earlier 12. So 12 by 10 will be 1.2. Parts into 1.2 is 1. Okay, and I will become now 2. Okay, now we'll get back to again. So num is greater than 0. Yes, it is greater than 0. That's correct. Then digit equal to num mod 10. So digit equal to num mod 10. So 1 modulus 10. 1 modulus 10 will give you again 1. Okay, so digit will become 1. Now sum equal to sum. So sum equal to sum is 19. 19 plus digit into, so digit is 1. 1 into 8 to the power I. What is I? 2. So 8 square. 8 square means 8 into 8, 64. Okay, 19 plus 1 into 64. So 1 into 64 is 64. 64 plus 19 will be 9 plus 4, 13. 6 plus 1, 7, 8. 84. Okay, 19 plus 64 is oh sorry 19 plus 64 is 83. Okay, 83 is there, and then num equal to pass into num by 10. So what will be there? Num equal to pass into num by 10. So this will give me 0.1. Pass into 0.1 is 0. So it will stop the loop here. So ultimately in sum whatever we have, that will be the uh, decimal value. Okay, so now let's save this and run this once. So what value I put? I put 1 2 3. So 1 2 3, and what I got here, oh I didn't print it, so we have to print the value here. After the while loop I have to do console.log out sum. Okay, save it, go to the browser, reload 1 2 3. I got 83. Can you see? We got 83 here. So this is how you can find the decimal, you can convert the octal number to decimal number. Okay, let's see some more examples. So here we had 764. Let us put 764. We should get 500 in the output. Okay, so a reload 764 and I get 500 in the output. Okay, now any more numbers? 65. If I put 65, I should get 53. Okay, 65. So I am getting 53. So that is correct. So this is how we can convert octal numbers to decimal numbers. Okay, fine. So we have seen how to convert an octal number to a decimal number. Now we'll see a similar type of problem, that is how to convert a binary number to a decimal number. Now what is a binary number? Binary numbers are nothing but they are numbers that are made up of only two type of digits, that is 1 and 0. Okay, so let's say 00 means 0. Okay, in binary system 01 means 1. Okay, 10 means 2. So here I am having 00, 01, 10. These are all binary numbers and these are decimal numbers 0, 1, 2. Okay, so 1 means 3. Okay, 100 means 4, and so on. This way the binary system goes on. But let's see the some more examples of binary numbers and how to convert them. So binary number. So we have here. So here you can see the conversion. Yeah. So binary to decimal. So here you can see what they are doing. In the octal system, we used 8 as a base, right? Here the same thing is to be done, but here we use 2. So first 2 to the power 0, then 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, like that. Okay. So we'll try to solve some basic examples. So here I have shown you 1, 2, 3, 4, 5. I'll take more values. Okay. 101 is for decimal value 5. 110 is for decimal value 6. 111 is for decimal value 7, and 1000 is for decimal value 8. Okay, so we'll try to solve some of these numbers, convert some of these numbers to decimal, and we'll check whether we are getting the correct output or not. Okay, let's see that. So whatever we did for the octal to decimal, okay, the same code we have to use, but instead of this 8 we have to write 2. That's it. Okay, so let me create a file, binary to decimal dot html. Okay, so where was the octal to decimal? Yeah, so I'll copy this whole thing and paste it here. So here, instead of 8, we'll choose the base as 2. That's it, no other change. Okay, same things will be happening. We'll take a number. Let's say we have to put binary numbers, not 1 2 3. Okay, binary number means, let's say 1 0 101. Let's say this is the binary number. What is the decimal equivalent of 101? 101 means 5. So that means if I put 101 here in the prompt, it will be, the digits will be separated 1 0 and 1, and then this whole process will be repeated. But instead of 8 we will put 2, 2 will be put as a base, and in the output, in the sum, we should get the output as what? 5. Okay, let's see. Let's save this, run this file, and see if I put 101, am I getting 5 or not. So 101, I got 5 here. Yes. Then let me put some other values like 1 1. If I put 1 1, I should get 3. So 1 1 is 3. Okay. So 1000 should give me 8. Okay. So 1000 is giving me 8. Okay. Fine. Let me put some other values. Like, what is this value? This value is 100 1010 1101. This should give me the value as 1197. Okay, so I put this number and I got 1197. So that means it is working fine. Okay, so this is how we can convert a binary number to a decimal number. We just need to change this base. In octal number this is 8, in binary number it is 2. Okay, that's it. Now we'll try to find out the LCM of two numbers. What is LCM? LCM means lowest common multiple. LCM means lowest common multiple. But what is meant by that? So let's say, let us take two numbers. Let's say 4 and 6. Okay. So first we'll find their multiples. The first multiple is 4 into 1 is 4. Then 4 into 2 is 8. Then 4 into 3 is 12. Then 4 into 4 is 16. Then 4 into 5 is 20. Okay, that's enough. Let's see for 6 now. 6 into 1 is 6. 6 into 2 is 12. 6 into 3 is 18. 6 into 4 is 24. 6 into 5 is 30. Okay, so now we have to check here. Both are having so many multiples, but which is the common multiple, which is the lowest common multiple? Okay, so first, if you see, 4 is not there, 8 is not there, 12 is there. So 12 is such a multiple of both the numbers, and it is the lowest. Okay, if you see, let me write more here. So 4 5 is 20, 4 6 is 24. You can see that 24 is also a common multiple, but it is not the lowest common multiple. It comes after 12. 12 is the lowest common multiple. So this is how we have to find out the common multiple. Lowest common multiple we have to find out. Okay, and we have to also think about, see, if we start from 4, so what is the logic behind finding the lowest common multiple? What we are doing is, we are taking the multiple of 4. Let's say 4, I am trying to divide it by 6. No, it is not divisible. I'm taking 8. Is it divisible by 6? No, it is not divisible. I'm taking 12. Is it divisible by 6? Yes, it is divisible. So 12 is the LCM. But the same thing can be done from this side. I can take 6. 6 is 6 divisible by 4? No. Is 12 divisible by 4? Yes. Fine. So 12 is the LCM. So see, I can get the 12 in 2 steps if I go for 6 multiple of 6. But if I go for 4 multiples of 4, I will achieve the same in 3 steps. Okay. 1, 2, 3. So it is better to go with the bigger number, larger number, so that we can achieve the LCM at a much uh, earlier stage. Okay, so this is what we will do here in the LCM logic. So what we do is, first let us get two numbers. So where num1 is equal to, let's say, 4, and then where num2 is equal to 6. Okay, so what I need to do here is, first I have to determine which is the, so as I told you, we have to go with the larger number, isn't it? That will be best. If we go with the smaller number, even then it is correct, but it will take a lot of time. Okay, so for that, first we'll check which is the greatest number. So for that, we'll create two variables. We'll have var large, okay, and var small. Okay, now we'll check for the condition, which one is greater, which one is smaller. So if num1 greater than num1 greater than num2, then large is equal to num1. Okay, else large equal to num1 and small is equal to num2. Okay, and else if num1 is not greater than num2, if num1 is less than num2, then large is equal to num2 and small is equal to num1. Okay, that's fine. So in this, at this stage, we will get the large and small in the large number and small number in the large and small variables. Okay, that's fine. Now we can start our logic. Okay, so what I'll do is, I'll write a while loop. While, what I need to check, I have to check whether this multiple of 6 is divisible by 4 or not. That means 6 mod 4, something like that. So what I'll write is, I'll write first large modulus small is not equal to 0. That means if it is not divisible, then what we will do is, so in the first stage, what is happening, I'm trying to divide 6 by 4. It is not divisible. That's why what I am doing, I'm taking the next multiple of 6. So how to take the next multiple of 6? I can do 6 plus 6. Okay, first time I'm checking, is 6 divisible by 4? No. So what I'm doing, I'm doing 6 plus 6 and I'm getting 12. Is 12 divisible by 4? Yes, I'm stopping. If it is not possible, then let's say I am taking 3 and 5. Okay, so let me show you 3 and 5. So 3 multiples of 3 are 3 comma 6 comma 9 comma 12 comma 15 comma 18. Okay, now I have the 5 multiple of 5. Okay, 5, what are the multiples? First multiple is 5, then 10, then 15. Okay, so what I need to do here is, first I have to take the large modulus small. Large is divisible by 3. So 5 modulus 3. Is 5 divisible by 3? No. So it is no. So what I am doing, 5 plus 5, 10. Is 10 divisible by 3? No. So again I am doing 10 plus 5. I am getting 15. 15 is divisible by 3? Yes. So this is the LCM. So I am adding 115 again and again. That means what is 5 actually? Large. So we'll keep on adding plus large plus large plus large, so that we'll get 5, 10, 15 like that. Okay, so when it is not equal to 0, when it is not divisible by 0, what we need to do is, we'll write here large is equal to large Okay, there is a problem here, large plus large. Okay, but there's a small problem here. Instead of doing large plus large, what I'll do here is I'll take the large value in s. I'll take where I is equal to large. Okay, so I'll put large plus I. Okay, not large plus large. If I write large plus large, what will happen? 5 plus 5 will become 10. Next time 10 plus 10, it will do 10 plus 10, but I want only 5, isn't it? So when I'm doing large plus large, the large variable is getting changed, so I don't want to change the variable. So instead I write large equal to large plus I. What is I is nothing but 5. Okay, okay, fine. So this will keep on increasing and it will keep on checking whether this is happening or not. And at the end, what we need to do, when the loop will stop, when the remainder is 0, when the condition is satisfied, is able to divide it. When 15 is divisible by 3, at that point it will stop, and then we can console.log of what we need to check is the large value. So at the large value, what will be there? Initially large value is 5, then we are doing 5 plus 5, large plus I means 5. So 5 plus 5 is 10, then next time 10 plus 5 is 15. So at this point it will stop and large will have 15. So if we console.log of large, we'll get the LCM. Okay, now let's save this and run it once. So what I got here, I got 12. Okay, so for what values I had checked? I checked for 4 and 6. That's why I got 12. Okay, if I write here 3 and 5, I'll get 15. Okay, that's the thing. So let's take another variable, 10 and 20. What should we get? Should get 20. 20 is the LCM. 10 and 25. What value I'll get? I got 50. Okay. If I take here 40 and 25, what will happen? I'm getting 200. Okay. So this is how we can find the LCM of two given numbers. Now we'll see a new problem, that is we'll try to find the sum of the numbers from 1 to 10. Okay, sum of 1 to 10. Okay, so how do I do that? So this is nothing but we need a for loop. Okay, inside the for loop I'll start it where I is equal to 1, I less than or equal to, where do we need to stop? From 1 to 10, right? So 10 and I plus plus, I equal to 1, I less than equal to 10, and I plus plus. Okay, so here what we have to do is we have to get a sum. So where sum is equal to 0. Okay, here what I'll do is sum is equal to sum plus I. Initially sum is 0, so first time 0 plus 1, next time 1 plus 2, next time 3 plus 3, like that it will go on. Okay, up to 10. After that we just need to print the value of sum. Okay, save this and run. So I got here, oh, there is a problem here. What was the problem? I wrote sum equal to sum plus 1. It should be I. Okay, because I value we have to add. So reload and we got 55. So the sum of the numbers from 1 to 10 is 55. Okay, so whatever value you put here, let's say you put here 50, it will get it as 1275. Okay, so now let's say I don't want to put it fix it like 1 to 50. I want to change the values on my according to my requirement. So for that what I can do is I can create a prompt, two prompts. That start equal to prompt enter the starting number and then another one, that is end, enter the ending number. Okay, so I will start from where I is equal to start and I less than or equal to end. Okay, it will start from start to end. Okay, and the remaining logic is same. To save this, go to the browser, reload it. It asks for the starting number. So let's say I want to get the sum of numbers from 4 to 8. Okay, I write here 4 and then ending number I put it as 8. So I'll get here 4 plus 5 is 9, 9 plus 6 is 15, 15 plus 7 is 22, 22 plus 8 is 30. So that's why I got 30. Okay, this is how you can find the sum of two numbers. Okay, in the same way you can also find sum of to find the average of these kind of numbers. Okay, whatever numbers you want to. So let's say to find the average of these now 4 to 8, what will happen? 4 to 8 means 4 5 6 7 8, that is 30 by 4 5 6 7 8 divided by 5. Okay, so console.log of sum by, what will happen? End minus start. So end minus start plus 1. Okay, we have to do this. You see here console.log of end minus start. What is the value? So let's say I write here 4 and 8. I got here 4, but actually 4 5 6 7 8. There are 5 numbers between 4 and 8. So for that I have to write plus 1. Okay, so now I can get 4 and 8. If I put, I get 5. 4 5 6 7 8. Okay, so what I have to do is console.log of sum by end minus start plus 1. If I do like this, I will get the average value 4 and 8. So 30 by 5 is 6. Okay, so let's say reload and 1 to 10 if I take, so 55 by 10 is 5.5. Okay, so this is how you can find the sum as well as the average to so what you can do is to find the average, you can take another variable where avg is equal to, you can write this part here and you can print the avg here. Okay, that's it. So 1 to 100, let's say the average is 50.5. Okay, fine. So that's how we can find the sum and average. Okay, so we have seen how to find the sum and average of a range of numbers. Okay, between two numbers. Now I want to say that no, I don't want to find the sum of all the numbers. I want to find the sum of only the even numbers. Then what do I do? So here I just need to put a if statement. Put an if statement. If I mod 2 equal to sorry, I mod 2 equal to 0, only then do the sum, otherwise don't do. Okay, so then we'll get the sum of the only the average numbers, sum of only the even numbers. Okay, so console.log of sum, I'll comment this average part. So let me check it. So did I write it in the same file? Yes. Okay, so let's say 1 to 5. 1 to 5 means what should be the values? Even numbers would be 2 and 4. 2 plus 4 is 6. Okay, so I should get 6. That's what I am getting. Okay, so in the same way if you want it for odd numbers, you can get it like this. So 1 to 5, then 1 3 and 5. 3 plus 1 is 4, 4 plus 5 is 9, so I should get 9. Yeah, that's it. So that's how you can find the sum of only the even or odd numbers between a range of numbers. I hope you got it. So let's say now I want to find the product of the numbers from 1 to 10 or product of the numbers between any two numbers. Okay, so let's start with 1 to 10. So what I need to do here is first here I'll have one product value. So product will be 1. Okay, sum is always 0 because we do addition. 0 plus 1, 0 plus 2. So 0 plus 1 will always give 1. That's why we keep 0 in sum. But in product we can't put 0. If I put where product equal to 0, what will happen? 0 into 1 will always give 0. So whatever we multiply with 0, it will always give 0. So we will not get the actual answer. That's why we put 1, so that 1 into anything will give you the same number. Okay, fine. So for where I is equal to 1, I less than equal to 10, I plus plus. So what I need to do here, product is equal to product into I. Okay, then console.log of product. So now we'll get the product from 1 to 10. So this is the big number that we got. So let's say we take a small number, product of 1 to 5. So what will be the value? 5 into 4 is 20, 20 into 3 is 60, 60 into 2 is 120, 120 into 1 is 120. Okay, so I should get 120. Yeah, I got it. Okay, this is how you can find the product of a range of numbers. Now if you want to make it what it is called, not from 1 to 5, you want to add it manually, then you can put these prompt things. So start, so where start is equal to prompt of enter a number, where end is equal to prompt enter a number. So you can write enter the starting number, enter the ending number. Okay, fine. Now here I will start from start and it will go up to end. Okay, so this will give you the, so from 3 to 6, it is 360. Okay, like that. Suppose you want to only find a product of only the even numbers, then you need to add a condition here. If I mod 2 equal to 0, only then do the product. Okay, we will get only the even numbers. So let's say I start from 1 and up to 6, then what will happen? 6 into 4 is 24, 24 into 2 is 48, into 1 is 48. So I got 48 here. Okay, so this is how we can get. So again you can put here odd number not equal to 0 means, so let's say 1 to 5 means 1 into 3 is 3, 3 into 5 is 15. So 1 to 5 I'll get the value as 15. Okay, so 1 2 even up to 6 you will get 15. Okay, fine. That's how we can find the product of a range of numbers. Okay, okay. So we have seen that how we can find the product of n numbers. Okay, from 1 to 10, 2 to 10, 2 to 5, all things we have seen. Now whenever we are finding the product of numbers from 1 to n, that is known as actually the factorial of that number. So let me show you something. Like if I say 5 factorial, which is known as factorial symbol in mathematics. So 5 factorial is equal to 1 into 2 into 3 into 4 into 5. Okay, this is equal to 5 into 4 20, 3 to 320 is 60 into 2 120. So 120 is the factorial of 5. Okay, so to do this, whatever we did earlier is the same to be done here. Okay, so where factorial is equal to 1, so that is where product is equal to 1. Same thing for where I is equal to 1, so it will always start from 1. Okay, I less than or equal to, let's say, 5 and I plus plus. Okay, so what I need to do here, factorial is equal to factorial into I. Okay, so this will give us the factorial of 5. Okay, so console.log of factorial. Okay, let's save this and run it in the browser. So I got here 120. Okay, fine. Now suppose I want to add it manually, like whatever number I give, I should get the factorial. Okay, so I'll do here where fact is equal to prompt of enter a number, and this fact I have to put it as the limit in place of 5. Okay, so it will start from 1 to fact, so whatever be the value, we'll get it in the output. Okay, so reload. If I put 5, I got 120. If I put 10, I got this 3628800. If I put 8, I got 8 factorial, 40,320. Okay, this way we can find the factorial of any number what we provide. Okay, that's it. Okay, so in this example, what we'll see is we'll try to find the nth power of a given number. Okay, so let's say we'll take two prompts. Let's say n is equal to 2 and r is equal to 4. Then what should be the output? 2 to the power 4. 2 to the power 4. What is the meaning of this? We multiply 2 4 times, right? Like this, and we get 16. This should be the output. We should not directly apply this exponent power. We should multiply 2 4 times and then get this. So to multiply this 2 4 times, we need a loop, isn't it? So let's see how to use that loop. So script where n is equal to prompt, enter the value of n, then where r is equal to plus prompt, enter the value of r. Okay, now we'll have product where the product will be stored. Product is 1. So we'll use a for loop for where I is equal to 1, I less than is equal to r, because it will go up to r 4 times, right? 2 to the power 4 means r times, and then I plus plus because n is the base. If n is 2, r is 4, that means 2 to the power 4. So r times we have to multiply. Okay, so product is equal to product into n. Okay, so 1 into 2 one time, 2 into 2 next time, then 4 into 2 third time, then 8 into 2 fourth time, 8 into 2 16 will come in the fourth time. Okay, so this product I just need to print it, console.log of product. Okay, save it and run this. So what I get here, first I put 2 and then 4, so 2 to the power 4 is 16. Let's say 3 cube, 3 and 3 cube is 27. Then let's say 10 to the power 10. What do I get? I get a very big number. Okay, let's say 10 and 2, 10 square, that means 100. Okay, So that means everything is working fine. So this is how we find the uh, nth power of any number using two prompts. Okay, fine. In this example, we'll be finding the NCR of two numbers n and r. This is known as combination in mathematics. Okay, so what is this NCR? What is the formula for NCR? Let's see that NCR formula. Okay, so we have here NCR formula is n factorial by r factorial into n minus r factorial. Okay, so that means in the question and in the prompt we have to take two values n and r. First we have to find the n factorial, then we have to find the r factorial, and then we have to find the n minus r factorial. That means three factorials we have to find, and then we have to apply it in this formula. Okay, we have to divide the n factorial by the product of r factorial and n minus r factorial. Okay, in the same way permutation can also be done. This is a simpler one, n factorial by n minus r factorial. Okay, so let us go with the combination NCR one. Okay, and then you can do the permutation on your own. Okay, okay, then fine, let's do it. So first thing, I'll take two values where n is equal to enter the value of n. So this one will be r. Enter the value of r. Okay, fine. Now first we'll find what we'll find first n factorial. Okay, so I'll create one variable, so n fact, then I'll have, so n fact will be equal to 1 initially, then we'll have where r fact is also 1, let's say, and then we'll have n minus r factorial, isn't it? So where I'll make it as difference of factorial, difference factorial. Okay, so I'll name it as diff fact. Okay, diff fact. Okay, diff fact is also 1. Okay, so these are the products. Okay, so now we'll start with the n factorial. I'll take a for loop. So for where I is equal to 1, I less than is equal to n fact. Sorry, n, I less than equal to n, and I plus plus. So this will calculate the n factorial. So n fact is equal to n fact into I, isn't it? So it will go up to 1 to n. Okay, so we'll have the n fact here. That is done. The same thing needs to be repeated for r fact as well. So I less than or equal to r, and instead of n fact I have to write r fact. Okay, we have both the values. Now we have to go for diff fact. That means n minus r factorial. Okay, so one more time I'll paste it. So here I less than or equal to, it will be n minus r. Okay, n minus r, that is the limit, 1 to n minus r. Now instead of this n fact I'll put diff fact. Okay, fine. So we got all the values. Okay, fine. Now we have the n fact, we have the r fact, we have the diff fact. Now we just need to calculate the formula. So NCR, I'll create one variable called, here only I can create NCR. NCR is equal to, what is the formula? N factorial, n fact divided by r factorial into n minus r factorial. So I'll make it a bracket like this. Okay, so what I do, r factorial, so that is r fact into multiplied with n minus r fact. So what is n minus r fact? That is defect. Okay, defect. So n fact by r fact into defect. Okay, so that is done. So I'll just do console.log of ncr. Okay, this will give us the value. Okay, now let us see some examples of ncr examples. We'll check that whether it is coming fine or not. Okay, so they are taking yeah, 5, this is permutation not combination. Yeah, 12c5. So 12 is the n, 5 is the r, it gives us 792. Let's check whether this is coming or not. Okay, so what is this 5? So 12 and 5 we have to put. So first is 12 and then 5. So what is the output? I got 792. That is the desired output. Okay, that is fine. Any more examples? Yeah, this is 18 and 4. That should be 3060. 18 and 4, 3060. Okay, so that means our NCR formula is working fine. This is the way to calculate NCR of two numbers. Okay, that's it.